Hi, good morning friends. My name is Viren and today I show you how to communicate with S71200 series PLC using the get put instruction in TI portal. First of all, open the software TI portal and you just see in the project tree there is a two. I have already insert two PLC1 and PLC2. My task is sending some data PLC1 to PLC2 and also receiving some data PLC2 to PLC1. So in this case we will use the instruction get input. So you just see I have already assigned the get input instruction in the PLC. This is the PLC1 block. Okay, so I have assigned the get input only PLC1, and you just see in the PLC2 program block, open the main program. This is empty, means it is no need if you have use get block in the PLC1. So definitely you need put block in PLC. No, nothing, because in the get and put instruction you just see both area we will assign our local memory area and our partners and our remote PLC area we will assign in the same block. So we don't need again for receiving block in the PLC2. But if you don't know what is the this parameter and how to assign the memory area, so you just click on the block and press F1. Directly get block, it is a help of get block is open, and here you just see there is a parameter list, declaration, data type, and the memory area, and this is the description. The request mean control parameter request activates the data exchange on the positive edge. Means this bit is high, that time only data will be exchanged. ID means addressing parameter for the specify the connection to the partner CPU. Means this is a address of the partner CPU, and the NDR means this is a status bit. If this bit is 0 means job is not yet started, otherwise it's still running, and this bit is 1 means job completed. And next bit, it is a error. If the error bit is 0 means your block is completely working. If error showing this bit is 1, and that time you see the some values in the status word, means some malfunctionings are there, and this is the different malfunctioning of condition. You just see if the error bit is 1 and that time the status bit indicate the 1, means the communication problem, for example. So this is the possibility, so we will easily rectify the problem. Next, address 1 means it is a pointer to the area on the partner CPU that are to be read, and the read one, it is a pointer to the area on the local CPU and which read data is enter. Means in address 1 we will assign the memory area of the partner CPU, and read 1 means read data we will assign the address of our local CPU memory. Now you just see open the configuration, and you just see first the connection parameter. Here we will first select the PLC hour. After this green indication check mark is coming, then go in the in the block parameter. First assign the request. It is a read area I 0.0 as a 2 and byte. This is the store area. If there is no indicator here, just assign just q 0.0, and here we select the 2 and here assign the byte. Means we received 2 byte data of the partner CPU side and store in the 2 byte in our local CPU side memory area. So my task is I received the input signal of the PLC2, and my PLC1 output should be on, and my second task is PLC1 send the input data to PLC2 and PLC2 output should be on. Okay, so now I have assigned the every bits. Same thing, so this is the get condition, and next same thing we will follow in the put condition. Here just see address and send data, here receive data, here send data. So our send data is input. So in the put block I am send the input data to PLC2 and PLC2 output should be on. So send data I have assigned the input data I 0.0 number of byte 2, and address means this is the address of the partner CPU. I have assigned the q 0.0 byte 2. So if I input is on in the PLC1, that time our output should be on in PLC2. Okay, so this is the basic configuration of the get put instruction. Now we will check. So first of all we will individually first download PLC1. The compilation program is started. and finish. Now PLC 1 is completely download successfully. Then PLC 2 download, load and finish. Okay. In the PLC 1, open the watch table. So this is the output of PLC 1, and again in the watch table of PLC 2. So this is the output of the PLC 2. Watch table 1, I have assigned the name, so you have easily identify. It is a name 1. It is a PLC 1 watch table, and this one is PLC 2. You just see first PLC 1, and I start the monitoring on. Okay. Okay. You just say get put logic PLC 1. So this output is for PLC 1. Right now is on. If I press the release the input of the second PLC, the output should be off. If again I press the input of the PLC 2, the PLC 1 output should be on. Same thing follow in the PLC 2. If I send the input command in PLC 1, the output should be on. If I release the input, output should be off. Now we will check the hardware, how exactly the PLCs react. Okay, I show you. Okay, so this one is my 1200 series 2 PLC kit. First one, this one is the PLC 1, and this one is the PLC 2. And in this my kit, you just see this is the switches. All the switches are connected with the input, and or the lamps. This is the lamp, and this lamp is connected with the output. And you just see I press the input of the PLC 1, and you just see the output of the PLC 2 is on. I press the input 1, you just see the PLC 2, the output should be on. Again I press the second input, and you just see the second output of the on of the PLC 2. And same case, if I press the input of the PLC 2 and first and second, you just see the PLC 1 output should be on. If I release the input of the PLC 1, the output should be off.